Research shows here that IQ scores are approximately normally distributed, so that means that we can use normal CDF and inverse norm to answer questions with a mean of 100 and a standard deviation of 15. So that is telling us here that mu is equal to 100 and sigma is equal to 15. We're using the calculator to answer the following. What proportion, so that's percent on the bell-shaped curve, of IQ scores are between 90 and 125? So these are the IQ scores. These are X values, not Z values. So we do need to specify our mean and standard deviation. They're not 0 and 1. So between 90 and 125, we can write that statement like this. So probability that a random IQ score X is between 90 and 125. So we're going to use normal CDF to answer that question. So if we graph here, we've got our normally distributed data. And then in the middle, we've got that 100, which is our mean right here, mean IQ score. And then we want to know what proportion is between 90 and 125. So 90 lower than the mean, 125 bigger than the mean. We want that area right there. So this is going to be normal CDF. And we're going to do our lower cutoff, lower bound of 90, and our upper 125, and then mean and standard deviation, 115. Let's go ahead and enter those in. So second variables, normal CDF, option 2, and our lower bound was 90, upper bound 125, mean 100, standard deviation 15. 0.6997. So 69.97% of the IQ scores are between 90 and 125. What is the probability that a randomly selected person has an IQ less than 115? So we'd write that like this, probability that X is less than 115. So if we sketch that picture, it's going to look like this. You've got your 100 in the middle, 115's over here on the right, and we want all the area less than. So our lower cutoff is minus infinity. We can use a big negative number. Upper cutoff is 115. So normal CDF. And for negative infinity, let's use negative 10,000. And then up to 115 is our upper bound, 100 for our mean, and 15 for standard deviation. Let's enter that guy in. So second variables, normal CDF is 2, lower bound, negative 10,000. And upper bound 115, and mean and standard deviation the same, 0.8413. And then lastly, is it unusual for a person to have an IQ of more than 150? So we need to find the probability that X is greater than 150. So that is going to look like this. Got our bell-shaped curve. IQ 100 is in the middle. That's our mean. 150 over here on the right. And we want a proportion greater than 150. So the area of that tail. So our left cutoff is 150. Our right cutoff is infinity. We can use a big positive number. So this will be normal CDF. Lower cutoff 150. Upper cutoff, we can use 10,000, mean of 100, and standard deviation 15. Go to the calculator. second variables. Normal CDF is 2. Let's see, our lower was 150, our upper 10,000, and mean and standard deviation the same. 4.29 times 10 to the negative fourth. That's what the E means, times 10 to a power. So 4.3 times 10 to the negative fourth. And that negative 4 means move the decimal 4 places to the left here. So this would be 0.00043. And they want us to round to 4 decimal places. So this would be approximately 0.0004. And is it unusual? They want to know, is it unusual? Well, that is certainly less than 0.05. So yes, this is indeed unusual. So anything less than 0.05 is unusual, anything greater is not.